Thanks for joining me live. All right, just fixing my Apple Pen. There we go. All right, so we are on exponential functions today. So if you have the notes, great. If not, you just write them on a separate sheet of paper. Not a big deal. So, we started talking about them a little bit last lesson. So let's begin. Excuse me. We have a function f of x equals 8 times 2 to the x power. So keeping in mind with that function, only 2 is being raised to the x power. 8 is separate. It's really like 8 a times dot 2 to the x. So let's evaluate. So if I want to find f of 2, that means I'm going to have 8 times 2 to the squared power, which is really 8 times 4, which is 32. And if you keep that in mind, that's really like we have the xy point 32. Next, we want to do f of 0. We're going to have 8 times 2 to the 0 power. 2 to the 0 power is just 1. So 8 times 1, which is just 8. So that's really your 0.08. Got a little messy there. 0.8. And if you think about the 0.08, if you were to graph that, it's actually going to be a y-intercept on the graph. Okay. And then if we want to do f of -1, we're going to have 8 times 2 to the -1. And if we remember with negative exponents from last lesson, that's going to switch that 2 from a numerator to a denominator. So we really have 8 times 1 over 2, which is going to give us a value of 4. So we really have the point -1, 4. So hopefully that's nothing too new. We could have also plugged this function in our calculator and looked at the table for each of those x values. That would have been valid as well. Okay, average rate of change. Been a little bit since we've done average rate of change. What was your policy on late work? Whenever it's turned in, you just get credit for it. So don't worry if something is late. Not a big deal. Side note, for last week's homework, you just have to take a picture of your homework sheet and email it to me. Or if you want to just join me on my office hours someday and show me like, hey, here's my homework, that works too for me. But for the ones that aren't in Delta Math. Like tonight's homework's not in Delta Math. It's going to be this PDF as well, which is in Teams. So good question. All right, so average rate of change, that's the fancy way to say slope, and it gives us specific points. It wants it between, oops, that's not the highlighter. Haha. It wants us between -1 and 0, which means I'm going to need to do f of 0 minus f of -1 all over 0 minus -1. Remember, those f of 0s, those f of -1, that's just the y value. So it's really still just change in y over change in x. I'm just writing it more of a function-y way since that's what we were given. So don't be too freaked out over that. So f of 0, its value was 8. So we're going to have 8 minus f of -1 was 4 all over 0 minus -1. Double negative, that's a plus. So we really have 0 plus 1. So when the dust settles, we get a value of 4. Now we're going to do the same thing over here. We're still doing average rate of change, but now it gives us 2 different points. Oops, I didn't want that color. I want pink. All right, so between 0 and 2 now. Now, if you remember with linear functions, when we did average rate of change, no matter what 2 pairs of points you picked, it was always going to be the same. With exponential, though, we're going to see it's going to be a little bit different. So we're going to do f of 2 minus f of 0 all over 2 minus 0. F of 2 was 32. F of 0 was 8. All over 2 minus 0 is just 2, so nothing too exciting there. And that gives us a value of 12 when the dust settles. So we can see that the rate of change between those 2 points was different. And that's okay, it's exponential, so it's growing at different rates as it goes. Answer question, what does comparing your answers from B to C tell you about this function? Since they are different, so since they are not equal, it is not a linear function. Because linear would have the exact same slope each time. This one does not. Now, if we were going to sketch this graph, and again, a sketch just means like, what's the general picture look like? Nothing too fancy has to happen here. We were going to sketch this. We had 0, 8 as our y-intercept, so I'm going to put that point here. Say that's 8. And then if we want to look at the picture of this in our calculator, if you want to type it in, you can. It's going to show growth. So, and if I wanted to estimate those other points, I could. So we had the points 232. So that's like up here, maybe. Maybe it's over a little bit more. Wasn't looking at my scale. There we go. Let's say 2 is here. Say maybe 32 is here. And then we had -1, 4. So that's going to be even smaller. So if we follow those points, we get this nice curve. Mine's a little sketchy. That's okay. So we can see it's getting, I'm going to fix the curve. It's going to bother me. It's ugly. It's ugly. There we go. Much better. So there's our function for f of x. So clearly not linear as we look at that. So that brings us to the general form of an exponential function, which is here, y equals ab to the x. So if you're writing these notes down by hand, this is something you definitely want to note. So a is our y-intercept, and b is the base or the multiplying factor. So if we look at the one we were given before, hold on, there we go. So the one we had before was 8 times 2 to the x. 8 was your y-intercept, and 2 was b, your growth factor. So if you have something that is greater than 1 for a b, that means that it is exponential growth. So let's write that down. So if b is greater than 1, it is growth. And we're going to get more specific with that in another lesson. And if b is between, but not equal to 0 or 1, but if it's between, so like a fourth or a half or an eighth or something like that, then it's going to be decay. So I'm getting ahead of myself just a little bit there, but just to give you some foreshadowing as what is to come. But that first number, that a value, that is going to be where it touches the the y-axis. Yes, the y-axis, your y-intercept. So this, super important. Make sure you get that down. Okay, so let's actually do a practice problem where we don't have, or we have that decaying growth factor. Oh, just heard my puppy bark in the background. All right, so we have g of x equals 54 times 1/3 to the x. So remember, we have y equals a times b to the x, where a is your growth factor, where a is your y-intercept, and b is your growth factor. So our y-intercept is going to be 54. So a equals 54, and our b equals 1/3. So what that tells me is when I go to graph this, my y-intercept is 54. So let's put it here. I'm going to skip around just a little bit. We have 54. Okay. So, and don't worry necessarily, I'm back, I was getting a bagel. Oh, hope it was a good bagel. So we have our function, we have our starting point, we have our growth factor, which I haven't done too much with yet. And don't worry necessarily about the specific window stuff. We're just going to kind of sketch the picture. So it says evaluate g of 0. So g of 0 equals 54. Oops, that's a bad 1/3. 1/3's not an exponent. What are you doing, Sadler? 1/3 to the 0. And as we said earlier, anything to the 0 power is 1. So we have 54 times 1, which is just 54. So definitely showing our y-intercept there. So you don't, it's a good thing. It's nice to memorize it because then you don't have to keep doing all this math all the time if you just remember it. Okay. With that, using your calculator, determine g of 1 and g of 2. All right. So g of 1, we have 54 times 1/3 to the first power. Well, 1/3 of the first power is just 1/3. So 54 times 1/3 is going to be 18. So we have the point 1 comma 18. And then if I want to find g of 2, we'll have 54 times 1/3 squared. So if we're going to evaluate that, 1/3 squared is really like 1/3 times 1/3, which is going to be 1/9. So we have 54 times 1/9, and that's going to give us a value of 6. So we have the point 26. So 118, 26, and 0.54 is what we have to work with so far. So if I was going to sketch those points on my graph, 118 is definitely lower than 54. And then 26 is even lower. So we can see with this picture, oh, that's a bad. Let me adjust this just a little bit. Okay. So this one we can see our curve is going down. Wow, I'm just not good at drawing today. I miss my whiteboard and my smartboard. Anywho, so it's about what our picture will look like. And again, you can plug this function into your calculator and get more of an accurate picture than what I can freehand. But this is showing that when you have a b value that is greater than 1, you'll have growth like the last example, and decreasing when it was between 0 and 1. The reason it can't equal 0 is because, well, that just kills everything off, so that's not fun. If something's equal to 1, it's not really growing or decaying. It's just staying constant. So, super important. I know we wrote it earlier, but here it is in all of its glory. So, without having to graph all of, what do you think you're going back to school? Do I think we're going back to school this year? I don't know, man. I'm in a group chat with a few of my friends that are teachers that you probably had in Holland. And I don't know. It's all up to the governor really at this point. I mean, it seems like he wants to open before the end of the year closes, but also Regents exams got canceled. So I would like to come back to school. I feel like if we do, it'll be like middle of May. I don't think it would be before that, but nobody knows. It's a mystery. It is a mystery. So, for each of the following exponential functions, give its y-intercept and tell whether it is increasing or decreasing. Yeah, Corona's still like super bad, and China tried to open up some of their non-essential like businesses and such, and now they're having another wave. So it's like, what are you gonna do? Glad I'm not a politician because I wouldn't want to make those choices. All right, so we're going to determine just by looking at this what its y-intercept is and if it's growth or decay. So I'm just going to rewrite y equals a times b to the x, where remember, a is where we start, which is your y-intercept, and b is your growth or decay. So here we have a y-intercept of 0, 8. And because it is less than 1, but still bigger than 0, it's not going to be negative, it's going to be decreasing or decay. Decay, 2/3 is less than 1 is our answer for that. For the next one, our y-intercept, or where we start, is at the point 0, 125. And this one, it's 1.5. So do you think it's growth or decay? Mm-mm-mm. 1.5 is bigger than 1. So let's say growth. 1.5 is greater than 1. And then our last one, our y-intercept, is the point 0, 56. And 3 halves, which 3 halves, if we just simplify that, is 1.5. So again, this one is also growth. 3 halves is greater than 1. Let's see. You should give extra credit to people who come to the live stream. I like that idea of giving people extra credit. However, I'm not technically allowed to make anybody create a Twitch account. So I am not allowed to do that. But you get like a kudos, air high five, for joining me. So I'm not lonely teaching to myself because I know the lessons. Had to pass it once upon a time ago. It says find the equation of the exponential function and y equals ab to the x form. Ooh, this is exciting. All right. So, but extra, I mean, it's still optional, but extra credit. We'll see. I won't count it out as of right now. I think today I'm supposed to find out what like our new grading policy is. I don't know. Like the powers that be, our meeting. And I'm obviously not on that meeting. So by the end of the week, I should be able to figure out that kind of stuff. I know. I remember. This is Andrew. Haha. I remember for once. Starting to learn everybody's Twitch names. All right. So we are given a table, and we want to find the equation of the function. So right away, I see 0, 10. That means I have, what's this? Oh, it's just y equals. So that's going to be my y-intercept. So if we're thinking about y equals ab to the x, my a value is going to be 10. So it's going to stay in y and x form. We just got to figure out what b is. Now we went from 10 to 30 to 90 to 270 to 810. This is getting huge, right? So because these are getting larger, it must be growth. So we got to think about, since our x is increasing steadily, by 1, what are we growing by? How do I get from 10 to 30 and 30 to 90 and 90 to 270? What am I multiplying by each time? Well, we are multiplying by 3. So that, very good. So that is the equation of our function. Bam! So awesome. So your homework tonight is to do the front and the back of this. Actually, when did I make this due? Hold on. Let me go to my other screen. Let's make this due on Friday. Yay, homework. Yes, because some of you guys are falling behind, so I want to give you a little time to catch up. So the homework, I'll make it due that's not how you spell Friday. That's not how you spell Friday. Come on, English. Blah. Who needs English? I think, like, the longer we're on break, like, the more my brain is getting fried. Let's see. Friday is the 17th. So when you do your homework, the PDFs and the files, like I said, just write down a separate sheet of paper, or if you want to print it, that's cool too. Just show it to me, either emailing it to me or joining me on my office hours. If you don't know when those are, shoot me an email. I'll let you know. They're on the Holland website, though. I'm watching animes. Oh my goodness. You're too much multitasking, sir. You also owe me the homework that was due today. So, homework due on Friday, and that's when I'll make your next lesson. So your next lesson will be lesson 5, which is a percents review. So a little bit of middle school action in there. So on Friday, we will do lesson 5. So have a fabulous rest of your day. As soon as I know more info about, like, grading and anything, I'll obviously pass it on to you guys. That's why I asked about the late work. Yeah, because I know internet's been weird. Like my internet randomly dropped yesterday, so I'm being pretty lenient with due dates. So just get them into me. Don't worry if it's like a day or two late. Like it's not a big deal. I'm not too worried. So have a fabulous day. I gotta go let my puppy out, and we will chat soon. Bye.